Hello everyone. In this video I'm just going to show you how to compute some basic statistics functions on your calculator. I will be using a TI-83 Plus from Texas Instruments. It's about the lowest style calculator that will work in this class. I know some of you have some higher models, maybe like a TI-84 or a TI-89, and they might look, the function might be a slightly bit different, maybe a little more sophisticated, but it's not going to be too much different than this. So I just want to show you how we can compute some of these things like the mean, the standard deviation, and so on without actually doing the calculations by hand. So here we have a data set of 28 test scores, okay, and we're going to compute all this stuff, the mean, median, mode, standard deviations, and so on. Some of these the calculator will give us directly, and some of them we have to do a little bit of work. Okay, so when you have a data set, first thing you want to do is enter them. So you first go to hit the Stat button, and since we're going to edit, we need to enter a data set. We hit Edit. And then you'll see a bunch of columns clear. Make sure one of them's clear, and then you can just enter the data one at a time. You want to do it, make it so that it's all in one column. Okay, so I've already entered these 28 values into the column L1. Okay, after you have done that, hit Stat again, and now you want to do a calculation, and we're going to be using first variable stats. So we choose first one variable stats, and then we just enter the column that we used, which was L1. Okay, so in this case we use the second function and L1, and enter that. And that gives you the statistics. Okay, so X bar, of course, this is the mean, okay, which is both the population mean and the sample mean. So this is going to be 80.179. We'll round to 3 decimal places. The median we'll come back to. The mode we have to compute by hand, so we'll come back and do that. The next thing we want is the population standard deviation, and that's down here where you see the sigma x. Okay, and that's 16.396. So it's 396, or we'll round to 397. And then the SX, that's the sample standard deviation. That's 16.697. or we'll round up to 698. Okay. The population variance we'll come back to. So will the sample variance. To find the minimum, and basically the 5-number formula, we scroll down here, and we see the 5-number formula. The minimum is 21. The first quartile is 72.5. The median is 84.5. The third quartile is 91.5, and the maximum is 100. So we can enter those here. Okay, and then the rest of the stuff we have to do by hand. Well, first of all, the median Q2 is already down here, so that's 84.5. And if you look at this, you'll see that there are 2 values that repeat more than once, right? It's 89 and also 77. Okay. Those are the most frequent data values. So in this case we have 2 modes, 77 and 89, and it could be possible that there could be more. Okay. With bigger data sets. As for the population variance, and the sample variance, they're the squares of the standard deviations. Okay, so for the population standard deviation, we square that. Now we said that that was, if we go back, it was 16.3969805. Well, we need to we would need to square that. And we want to add a few more digits to this. So the population variance is going to be the square of 16.3969805 squared. And similarly, the variance, sample variance, is the square of the sample standard deviation. So this is 16.69786762. Okay. And so we can compute that. So this would be, this is going to be 16.3969805. Okay, that is going to be 268.86, just round to 2 decimal places, and if we square this, 16.697866762, square that, we get 278.82. Okay, so you can see the variance is much larger than the standard deviations, but we're just squaring them. You just want to take it as many decimal places as you can to be accurate. And then finally, the range, of course, is the max versus the min. That's going to be 100 minus 21, right? Which should be 79. And the IQR, this is, remember what this is Q3 minus Q1. So this is 97 or 91.5 minus 72.5. And that is 19. And so that's the interquartile range. And you can see using our formula, we can see that we have exactly 2 outliers from this, right? I think you can see what they are. They're 21. 21 is certainly an outlier, whereas that's right here, and also 49, which was right here.